Hello, 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 hello. We should be live. I need to double check that. Let's see. View my channel. Okay, yeah. Looks like we are live. Alright. Good evening. So this evening, I think what I've decided to do, following up on yesterday's read of an article by Lauren Hochstein, I think. I think it was called something about formal specs on programs. I wonder if that will just, yeah, as I said, of behavior. Yeah, that was the one. So yeah, we read that yesterday, and I mean, these are all tools that I've been aware of, but I've never actually tried them, at least not extensively. So I figured maybe if I can at least try one of these and make some videos slash streams where I try it out, that could be interesting. So yeah, that's what I'm gonna do. We are going to go through the very, I guess, the introduction to FizzBee. It's one of those specification languages. I guess you can say it's one of the newer ones. It's and I mean, as you can see, even in its own description, they try to make it, programmer friendly in terms of the syntax. And I guess one of the inspiration is Python in terms of the feel as far as the syntax goes. So yeah, I guess we'll just do the getting started guide, and yeah, let's see how it goes. Okay, so this tutorial assumes that you have a basic programming experience and are familiar with Python programming language. You don't need to be an expert in Python, but if you have written some algorithm, if you have written some algorithms or scripts, you should be good to go. Alright. FizzBee is an open source project and is available on GitHub. There are no built binaries. You need to build the binary using Bazel. The instructions are posted in README. Yeah, I don't think I'm doing that. I think we'll just use the online playground for now. Want to avoid the whole yak shaving problem of you have to do the setup before you actually get in the game. And yeah, if they have an online playground, let's just use that. Okay, so writing your first FizzBee program. Hour clock example. Let's model a simple clock that ticks every hour. Run the code and try modifying the code to see how the model checker behaves. Excuse me. Did this work? Yeah, okay. I was trying to see if there is a no, that didn't work. So I have to press it. I was hoping there was some sort of key binding or whatever it's called to be able to press the run button without having to use the mouse, but anyway. State graph. Okay, so you have a tick. So that increments the hour. So 3 actions, 3 forks. I don't know what that really means. Okay. What does this say? Config files, state space options, mass actions, liveness strict, deadlock detection, true. Okay. Okay. Model checker completed successfully. Okay, so the initial state is we start with hour 1, and then we have an atomic action called tick. And if it's 12, we set it back to 1. If not, we just keep incrementing. Okay, that's straightforward enough. On the right side, you'll see the output of the model checker, and a link with states graph will show you the states the model reached. All right. Yeah, you can simplify it using the modulo. Nope, wrong. Wait, how do I? Whoa. No. Jesus, I forgot how to. Never mind. I guess now it's not the time to figure it out. Okay. I mean, it should give us the same thing. I mean, the example here is really to just show us the example here is just to show us that you can use some pretty familiar expressions in a language like Python. Like it, you look at this and it looks like Python, right? So that's the developer friendly aspect of FizzBee, one would say. Alright, actions. Actions represent the actions that can be taken in a system. There could be something a user does. I mean, this could be something that a user does, or a system event like a timer tick and so on. In the above code, we have 2 actions, init and tick. Init is a special action that initializes the system. It's called only once. Make sense? Atomic keyword is used to denote that the action is atomic. We will revisit this later. Tick is our main action that increments the hour. If the hour is 12, it resets to 1. An action indicates what can happen to the system. Okay. So far, so good. I mean, this is obviously very similar to the actions in TLA Plus, to the best of my knowledge. Syntax. The meat of the code is written in star-like language that is a subset of Python. So the body of the action will be familiar to most programmers. Most of the constructs like if and else, for and while loops are similar to Python. Similarly, most common data structures like lists, dictionaries, tuples, and sets are also similar to Python. Nice. Alright, this is pretty straightforward. While is less than 5, blah blah blah. Same as Python for. Okay. Wait. Okay. Value equals 0 for x, for loop. Okay, let's run it. Okay, we do see value is equal to 6. Oh, there's a deadlock detected. Interesting. Model checker failed. Why is that? Is that supposed to happen? Why would there be a deadlock? Like something about the value here being incremented. Okay. Are they gonna mention it? Oh, okay. Well, let's just move on. But that is at the very least interesting. Okay. The any keyword is similar in structure to the for loop. The only difference is that any indicates any one of the values in a list can be chosen. So I was just double checking if okay, so this is understood to be a normal for loop in the way that we think about for loop. This is the interesting bit where you're just picking some value. Are you picking a random value three times or just once? Okay, exploring any one of these, I guess choosing any one of them in some order, right? In this case, it only chose one. Oh wait, so okay. Wait. Okay, so it chooses only one of them. It doesn't choose any one 3 times. It's choosing exactly one value out of the whole, I guess, sequence or set or list or array, whatever you want to call it. I'm still not very sure. I don't think I understand what the forks count here mean, really. I mean, I get the output here, meaning, in this particular branch we chose 1, here we chose 2, and here we chose 3. But I don't understand exactly what this part means. Okay. So with a for loop, the value will be 6, but with any, the value can be any of 1, 2, or 3 at the end of the init action. Any syntactic sugar. In many cases, there's no step to be taken if nothing matched in a list of values. You can use this simplified form. Require. Okay, I guess they'll explain it later. What the require means. So is this basically saying that I mean, is this assuming that this is only gonna run once? Because, I mean, if this was running more than one iteration, then this would be violated, right? Because on the first one, it chooses some value, which is clearly greater than, strictly greater than 0. So if there is another iteration, this should fail, I think. So, I don't know. I guess we'll find out about what require means. Anyway, condition, okay. A condition can be specified when using the any keyword. This is helpful when you want to choose a value. Okay, so there is some dependency between x and y. You want x and y such that they're either 1, 2, or 3, as long as x and y are not the same, such that. Okay. Let me write this by hand just to build up some muscle memory here. Actually, can I? Since I'm not using this side for now, let me just put this here. Like that. Let's actually type some stuff to build some hands-on feel of actually writing this. If I can type. Okay. Gosh, am I crazy? I feel like there should be a way to trigger this run without me having to use the mouse each and every time. Alright, okay, the downside of having this shrunk this way is that you don't really get to see what's happening. Oh, yeah, I actually didn't look at my screen. Probably should make this bigger, like that, I think. Yeah, okay. What's happening here? Refresh the page. Okay. Right. Where were we? Okay, we were here. And I typed that in, and we got, oh shoot, my big head is in the way. How about we do this? Okay, that's better. All right. Okay, so we start with an empty state. Then we choose X, which is 1 in this particular run. Well, okay, I guess it's not really state. These are just, I guess, local variables at this point. But then, why is that not x1? And it's only after you set y that you get a state. Like I mean, intuitively, or I guess just by looking at this, I would have expected this here to be x1, or to have x, x1 after we chose a value for x. Okay, so that's interesting. Block modifiers. Block modifiers are used to specify the behavior of the block. So atomic block, the atomic block modifier is used to specify that the block is atomic. An atomic block is, an atomic block is executed as a single step without any yield points in between statements. If two statements are executed atomically, either they both are executed or none are executed. So really, you can think of it as, database transactions, some atomic counter. It's all or nothing, basically. All right, let's do some typing again. So A0, B0, action add. Okay, so we can have blocks. Can type B equals B plus 1, 3. Okay, so we increment A and then take modulo 3. Okay, let's run that. Auto checker completed successfully. Okay. Note the block modifier of the top block can instead be specified at the action level. Oh, okay. So you can just place it here. Oh, one thing I just realized is this ain't all about okay, yeah, I think it is indentation, just like Python. Let's see what happens when I do that. Yeah, okay. Alright, so just like Python, it's very particular about indentation. Alright. Okay, let's see. One of block modifier indicates only one of the statements in a block will be executed. And I guess this is up to the can I actually put it here? Just like oh no, that was a misspelling. Yeah. Okay, so I can also modify it, use the modifier at the action level instead of having it inside like this. Oh no, what did I do? Okay, like that. Nope. That's what I wanted to do. Yep, that works too. Okay, so modifiers. You can do them at the block level, or well, at a block inside the action, or you can do it right at the action. So, okay. Good to know. All right, serial. Serial block. Wait, okay, the last one was one of, so we have atomic, one of, and serial. Serial block modifier indicates the steps will be executed in sequence one after the other, and there will be an implicit yield point between each step. When there is a yield point, in addition to the fact that a concurrent action can be interleaved, the system could also crash, implying the latter steps may not always be executed. Interesting. So atomic, you want all the things to execute together as one. One of. So it sounds like the assumption here is that with one of, you really only have two expressions, right? It's an if or else branch, sort of, and the checker or the simulator, whatever you want to call it, picks one of them at random. So this wouldn't apply if I had. I guess we can find out. That's the beauty of having something to play with. I think it's really nice when you start a new language and they have a playground like this that you can just start toying with, instead of having to, install things on your machine and everything that goes along with that, the yak shaving. Anyway, so this is nice. So Actually, I think I need to first do, no, how about we do that? And then we do C plus 2, because why not? And let's do 3 as well. What happens? Oh. Oh. Well, actually, yeah. Why did I? Yeah, why? Jesus. Uh, yeah, this is why you actually try stuff. Because sometimes you form these theories in your mind, but then you actually put them into practice and you realize, what the fuck? Why? Well, that was dumb. Why was I thinking that things would happen this way when, if I took another just 3 seconds to think about it, it would be like I would have been able to, figure out that that was wrong. So one of, really, it doesn't matter if you have shit. It doesn't matter if you have even nothing. In fact, it doesn't matter if you have, actually, can I comment out? How do I comment things out? Oh, yeah. Awesome. It's with hashtag, I think. Yeah. It doesn't matter if you have 1, 2, 3, or a billion. One of just literally means one of. It's like, yeah, choose one item out of n items. So, scratch what I said about it's like if else branching, and you pick one of, and it has to be 2 branches or 2 options or 2 expressions. That was stupid. That was dumb. Um, Actually, now I'm curious. What happens when you don't specify anything? I think it just kind of, yeah. Okay. Um, One of empty. You're choosing one element out of an empty set, basically. You know, it's nothing. Oh, wait a minute. Okay, actually, this is a syntax error. Okay. So this is syntactically not correct to write. All right. Okay, one of. Serial means every single one of this will be executed, but in between, you can think of it like, I guess, async await. And you can think about the fact that each item here, maybe this is your async, right? And oh, async is actually a keyword. Ooh, interesting. We'll see what that's all about. So I don't know. Would you put the? I mean, now that I know async is a keyword, I wonder if await is a. Yeah, it seems like it's a keyword. I mean, it looks like it's a keyword. The question is, do we put it here, or do you put it here? I mean, if it's like Python proper, then I think it will be something like this. But obviously that's not what we are doing right now. But my understanding is that, so I mean, it says it. There's a yield after each and every step, and I think you can kind of think of it as the yield that you have in the async await concurrency model. Okay, when there's a yield point, in addition to the fact that concurrent action can be interleaved, the system could also crash, implying the latter steps may not always be executed. All right. So action init. Okay, yeah, we just try that. When a block is not specified, the serial block modifiers. Oh, okay. So by default, if you don't, this is the same as this, basically. Actually, let's run this. Okay. Should basically get the same output. All right. Parallel. Parallel block modifier indicates the steps will be executed in parallel. What time is it? Okay, sorry. Parallel block modifier indicates the steps will be executed in parallel, and there'll be an implicit yield point between each step. When there's a yield point, in addition to the fact that a concurrent action can be interleaved, the system could also crash, implying the latter steps may not always be executed. That is, if there are two statements in a parallel block, the model checker will explore these possibilities. So A, B, A, B, B, A. Okay, execute in parallel. And there will be an implicit yield point between each step. Well, in this particular case here, if they're executing in parallel, I'm struggling to like a concurrent action outside of this one, I assume. I mean, yeah. Between each step. But if the steps are happening in parallel, how is the how's the yield relevant here? Huh. That's fuzzy to me. Yeah, that's not clear to me. But let's run it. Is it still running? It would be nice if there was some sort of indicator, because right now I have no idea. Like it doesn't look like this has changed at all. Um, hmm, this is not very helpful. Oh, not very helpful there. Um, like I really don't know if this is actually running this here. Like I can tell. And I guess I can watch for this part here. Oh, okay, it is changing. Okay. What about the states graph? Not getting anything. Oh well. Let's just power through it. Okay, correctness. This is the most important part of the model checker. When exploring the state space, we need to ensure the system does what we expect it to do. There are two types of correctness. Safety, something bad never happens. For example, the API should never return the wrong value. Liveness, something good eventually happens. For example, the API should eventually return a value. Combining these two, we can specify the correctness of the system. For example, the API should eventually return the correct value. Let's take a simple example of a counter that increments by 1 until it reaches 3, then resets to 0. But the starting value can be in range -2 and 2. That is one of -2, -1, blah 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 blah. Okay, let's type this out. Any x in range 1, 2, 2. Value x. Okay, so that's the initialization. Then we have the atomic action add. If value is less than 3, then value. Shoot. Where's my equal? 1 else value equals 0. Okay, I can dig it. Feels good to write. I'm not gonna lie. Feels better to type than TLA plus. So far. Yeah. Alright. Let's run it. Alright. Looks like we're good. Okay, safety. I don't know, where are we in this? Oh, we have plenty to go. Okay. Let me see. Oh, it just keeps going. Jesus. Alright, let's see. I'm just trying to level or get an idea of where we may want to stop and pick up later. So maybe we do let's do safety and liveliness or liveliness. Okay, no, liveness, not liveliness. Okay, liveliness, and maybe also fairness, and okay, everything before God closes and enabling conditions. Let's do that. And then we'll call it. I think that would be a good first part video or stream or whatever. Okay, we are here. Safety. State invariance. Safety is specified using the always keyword. In this, the safety property is the value should never be greater than 3 in this code at the top of the file. Add this code. Okay, sorry. Alright, let's do that. Always assertion always less than 3. I do wonder why we need the extra assertion keyword here. Alright. Let's of course run it. Looks like it passed. Does it tell me if it would have been nice to get some sort of indicator here that says, you know, which assertions are passed or failed specifically. I don't know, maybe it's just, maybe there's that metadata is available, it's just not being displayed here. Okay, so safety violation. If you change the invariant to always value, so if we do this, they're saying yeah, that will be a problem because x can be 2, right? It's inclusive, right? The range. Oh no, it's okay. No, it's not inclusive. But if during initialization you get, well, actually it doesn't matter. If you get any of these eventually, at least based on the way this code is written, you'll get to a point where you get x is equal to 2, which will be a violation here. Although if you were to do this, no, that would still be bad. Yeah, I think you'll just have to change something here for this to pass. Let's see if I'm right. Well, this part we expected, right? This one, but if we did this, right, it should be pretty straightforward. It should pass. Yeah. Okay. Okay, no, that's not where we are. We are here. if you change the invariant to always value less than or equal to 2 and run the code, you will see the model checker will show a violation. Yeah, okay, so we did that. Now the model checker will show a violation, blah blah blah, something something. Okay, let's just keep going. Transition invariants. Although in most cases the state invariant is sufficient, there are cases where we need to assert on the transitions whether a state can change from a certain state to another state. For example, a committed transaction cannot be rolled back. This is done using the transition keyword. Alright, let's see. So max hour. Max hour is 12. Oh, so we can have global constants, I guess. Right. And action init. So our meridian atomic change. Take the modulo. Max hour and add to 1. Another atomic action. Okay. So a transition. Wait. Okay, this is an always. This is a transition. Okay. Before, after. Alright. So if the margin are not the same between the old state and new state, wait. Okay, change from 11 p.m. to 12 a.m. Excuse me. What's max hour again? 12. Okay. I guess I'm not. Okay, so these are predicates. Not actually changing any values. Okay, so if you change from AM to, I don't know, from AM to PM or PM to AM, we need to make sure that the hour before, yeah, but this can either be AM or PM or PM and AM, right? If they are the same in this particular branch, if they are the same and before hour is 12, and after hour is 1, which means that we are um, wait, then what? Just realize, you can't really differentiate between AM and PM in that particular case. Ba, 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 ba. Wait, if they are the same, what am I missing here? So 12 a.m. and 1 p.m. Or after hour. After hour is equal to before hour plus 1. Yeah, okay. I mean, this is straightforward. Like if they're the same, if you're 1 p.m. and 2 p.m., then it's just an increment. If you're going from 12 to 1, okay. Oh, yeah, because, okay. Oh my god, what time is it? Yeah, 10 11 p.m. Yes, so that was slow to come, but it did come. Yes, so if they are the same, you're either doing a normal transition, as in without any weird numbering cycling or number cycling, where it's, either you have something like 1 a.m. to 2 a.m. or you have 1 p.m. to 2 p.m. Or you can have some number cycling where you go from 12 p.m. to 1 p.m. The meridian are still the same, but now you're, resetting to 1, going from 12. Same thing for 12 a.m. and 1 a.m. And yeah, this one we already went through that. So this, okay, I guess the assertions, assertions or predicates. Just either have a transition one or a safety one, I guess, and always. Okay, so when you see it, when you run it, you could see the error. Let me just copy and paste this. Wait, I thought there was a copy button. Where is it? Okay, yeah, there it is. So we started with that. Then we have a meridian change. Okay. I'm not getting any error, by the way. So, oh, error graph, sorry. Alright. I feel like this is good metadata to have. Okay. So there was an error. Except I don't think I'm... So when you make the change... Okay, it's probably... Okay, it's changing because of the assertion that we have here. Because then this will be the before and then this is the after. And that will be in violation of this particular clock behavior transition. So we will actually fall in this particular branch here, right? Where the before meridian and the after meridian are different. But before hour, in this case, is not equal to 11, which is what we want here. And the after hour, the after hour is equal to max hour, but before hour is definitely not this, and so we have a failure. All right. Hour change. Oh, okay. There it is. States graph. So starting from the initial action, we can either go hour change or meridian change. And the hour change is pretty straightforward, just increments 1, which is completely fine in this case. So 12 a.m. to 1 a.m. So we're golden on that front. But then when you choose the other branch or the other action, that's when things get fucked. All right. So they proposed this as the change. Let's see, meridian change. Wait, why is this wrong? Let's see. So if our... Well, okay, what was the original? Okay, so here it says if hour is equal to max hour, so 12. Meridian is PM. If meridian is AM, so 12 AM. Now you want to check, you want to change it to 12 PM. And that doesn't work. So this is basically saying if you're 12, just flip the meridians. Yeah, that doesn't work. Okay, this is back. Actually, I think I want the states graph. Yeah. So when you pick this, yeah, here you're just literally just flipping. And here you're saying, so if it's 12, now you make it, wow. Okay, you're saying once you reach 11, which can be either 11 a.m. or 11 p.m., you're saying to go to the next state, that you need to flip the switch. I mean, flip the meridian, which again doesn't work because then if you have 11 a.m., you're going from 11 a.m. to 11 p.m. and then from 11 p.m. to 11 a.m., which is ridiculous as well. So let's show that by, need to remove this. Oh, it's a lot of hour change. Let's do another run. I was hoping for something that was more. Okay, I guess just gonna keep trying until we get something, a state graph that's less. Okay, fine. Actually, I guess it doesn't matter at which point the meridian happened. The moment the meridian thing happens, the meridian change action happens, that's when things just go to shit. Yeah, so it's equal to 11, and it just kind of flips the meridian, which again is not true because you're supposed to go here, you're supposed to go to 12 p.m. Correct fix. We take the modulo based on the max hour, and then we'll do +1. And if the hour is max hour, okay. All right. Okay, so here, if hour, let's say hour is 12, then 12 modulo 12. Basically, we end up with 1 here. So we don't need to do anything. But if we are 11, the modulo gives you 11 plus 1, that's 12. So now you know that you need to do the switch, right? Because you're going from 11 to 12. So from 11 a.m. to 12 p.m. and from 11 p.m. to 12 a.m. And so you make the switch here. Hours change that, and I think you can remove this here. All right. Okay. So let's do liveness. Well, the liveness, I don't think we'll make it to fairness for this first session. All right, let's do liveness and end it there. All right, liveness. Liveness is specified using the eventually keyword. In this example, the liveness property is the value should eventually be 0. Did I miss something? When did that? Did I miss something? Is my brain too foggy right now? Okay, what do I mean by this example? Anyway, let's move on. The liveness property is the value should eventually be 0. But for most practical cases, we need to combine with always. Always eventually. So there's always eventually or eventually always. Okay, always eventually. So eventually, it is always the case that eventually something will happen. Eventually always is actually more straightforward because it's like eventually, a value happens and then it basically stays that way, right? Trying to think of a real world example. Eventually, Lionel Messi or Cristiano Ronaldo will retire from playing soccer, right? Eventually, they'll retire. So it's eventually always a soccer player retires. As silly as that, it's a very contrived example, but you get the point. Eventually, always. So, you can also think of, I don't know, one of those static lazy what are they called? Static lazy, I don't want to use the word variable, but sure, why not? Static lazy variables in Rust, where you declare them, and then once they've actually been set, they never change after that, right? Now, always eventually. Let me think about that one. feel like I get it, but I'm also struggling to find a concrete example that's like really clear. Eh, let's just read the thing. This means given enough time, the behavior will always reach the desired state eventually. For example, the above counter will eventually reach 0. It can go above 0, but it will again come back to 0. Okay, so you can have deviations, but eventually you settle at a given value. Always eventually value equals 0. Always eventually value equals 25. Okay. Yeah, that one is a little tricky to fully internalize. Always eventually. I feel like it's meant to declare that a given object or whatever can hold different properties that are all a different set of properties that are all valid. And that's basically, the set of accepted states. Yeah, I don't know. Need to internalize that one. This one is pretty straightforward to me. This asserts the behavior will reach the desired state and stay there. Yeah, like very straightforward. For example, the above counter will eventually reach 0 and stay between 0 and 3, inclusive. Even though the value might start negative, this is expressed as eventually always value greater than or equal to 0. Yeah. I don't know, do we have time for fairness? Maybe we do. No. You know what? Let's call it. We'll resume. Can't make any promise about tomorrow or even Thursday, but definitely next week. So if not tomorrow or Thursday, we'll resume with this getting started guide with FizzBee. Overall, I mean, this is fun. It's been fun to go through this. I mean, I had heard about FizzBee some time ago. Heard good things about it. Obviously, the fact that the syntax is what it is helps. So yeah, I look forward to resuming this another time. Yeah, I guess this is good night, and I'll see you guys around.